we're going to look at primary trig ratios. So we're actually going to list the primary trig ratios, and they're usually set up like this. Sine. Do you guys use a symbol like this? Have you ever seen that before?
No,
Theta.
we just do like the line through.
You do a line through it? Okay, yeah. There's a curl or a line through it, whatever it is. The symbol means theta. All it is a variable. That's all it is. You could have called this sine happy face, and it just represents an angle. In math, we use symbols to represent unknown values, okay? So a very common one in math is to use theta for an angle. So sine theta is equal to what they call is the opposite side of the triangle divided by the hypotenuse of a triangle, okay? Which means we're going to have to label the triangles just so we know. Cosine theta, okay, so cosine of some angle is equal to the adjacent side of a triangle divided by the hypotenuse. And then the third one is called tan. Tan theta is equal to the opposite over the adjacent side. Okay, so there's always three sides that we're talking about. What's interesting about this is opposites and adjacents can change. Hypotenuse can never change. It's always going to be one value. And the value of the hypotenuse, or the place of the hypotenuse, will always be opposite of a 90-degree angle. You can only use these with 90-degree triangles. Any other triangle that's not 90 degrees, these actually fall apart. You cannot use these, and that's when we get into sine law and cosine law. So we have this piece. We know that this 21 happens to be the hypotenuse here, which is good. We now have a value. So if I were to try plugging things into the hypotenuse, I already know that I can plug 21 in for both of those, okay? Opposite and adjacent is extremely dependent on which angle we're talking about. And there happens to be two angles right now. We have this angle, which is 54, but there's also this angle here. I can actually figure out what it is because I know a rule about triangles. And the rule of triangles is angle, we'll say A plus angle B plus angle C will always equal 180. Yeah. Now, this one, while they haven't given us any numbers for it, we know that that is actually 90 degrees. So maybe I'll call that B, okay? So let's call this A, B, and C. Well, angle A is 54, so I can replace 54 with that. Angle B is 90. The only unknown here, instead of putting that angle symbol, I'm just going to call it C for now. It's equal to 180. Well, if I do some algebra, I can isolate for C and I can get a value. I'll tell you that it ends up being 90 minus 54, which is going to be 36. So, turns out C is 36. Now, you could have used a calculator or something to solve that. We're not going to use that yet, but I just want to keep that in our back pocket. It's good to, like, when you see something, even before you know what the question is, what information can I already start to gather about this question? Okay, so I'll write it in there, but we may not use it yet. We know this one is 36. Okay. When we go to set up these ratios, we have to choose an angle. We'll choose the one they gave us. It's probably most intuitive. This is what they've given us, so we'll call this theta, this angle, which now means we can name the rest of this triangle. We have to find what's opposite of theta. Well, opposite of theta means the arms. So we have like two arms of this triangle. The opposite would be the arm that does not touch it. So this would be the opposite in that case. And then by deduction, we already have a hypotenuse. We already have an opposite. Yeah, exactly. That one must be the adjacent. Okay. It also means to be touching. So this is a side that's touching the angle. The only problem with that is the hypotenuse is also touching. So I don't want you to get confused with those two. Always start by labeling hypotenuse, then the opposite, and then, the last one left over has to be the adjacent side. Awesome. Okay, so if that is true, our question becomes, which of these ratios, because we start setting them up, will help us solve x? So we'll start setting them up. I got sine. I'm going to say sine theta is equal to, and they'll say O over H. That's very often they'll call it, okay? Well, theta, we know, it's 54. Sine 54 is equal to the opposite. Opposite, we haven't even given it a value. Let's call it something. I'll call it y in this case, okay? So y over hypotenuse, I could write that, but I have a value. I'm going to write it in. Over 21. Okay, so we've set up one of the ratios. I'm going to set up all three here. Okay? Cos 54 is equal to adjacent. Well, the adjacent side is what they had called x, over the hypotenuse, which was 21. And then we have tan 54, which is equal to the opposite, and the opposite in our case was y over x. Now, we have three ratios. Our goal is to solve x. So, let's look at the first one. Do we even have an x in this one? No. So this one is not going to help us. It's good information, but it's not going to help us solve this. The second one, does it have an x in it?
Yeah.
Yeah, this looks pretty solvable. What about that third one? Does it have an x? It does. But there's something wrong with it. At least in terms of our ability to solve things. We're going to run into a problem here. Any idea what that problem might be?
The y.
Yeah, we don't know what y is either. I have two unknowns. And in math, if you have one equation, in order to isolate, you need to have only one unknown. If you have two unknowns, you can't get a definitive answer. If you have two unknowns and two equations, you can do it. If you have three unknowns and three equations, you can do it. But in this case, we only have one. So because I have two unknowns and one equation, this one's not going to help either. I just have too many unknowns, which means by default, this is our winner. We're actually going to need to use cos to solve this. At this point, function, you'll plug this into a calculator. So cos 54 is equal to x over 21. And then when we go to isolate x, we're going to multiply both sides by 21. Okay. So on your calculator, you're going to type in 21. Do you happen to have one handy or no?
Not like...
That's okay. I'll bring one up online. Is equal to x. What I'm going to do is, let me see if I quickly got a calculator handy. We've got, that's a course outline. Here we go. Let's get Desmos. Calculator. There it is, scientific. Okay, I'm going to plug this in. Now it's in degrees, and our question stated it was 21 times cos 54. There we go. It's given us a value. It's approximately 12.3, we'll say. So let's jump back over and Desmos scientific calculator. There you go. So according to this, x is approximately 12.3, okay? Now, my question to you is, if you'd use the other angle, okay? Let me zoom that a little farther. But if you use the other angle and you set up your ratios, which ratio will help you solve for x in this question? Okay, so that's what I'm going to put as a challenge up to you right now. And let's stop it.